All right, so now we're going to be going over quiz number 2 from in class on September 23rd. So, number 1, we're going to have our rows and our columns are equal to the size of 1's 2, and that concatenated with our D matrix. So, 1's 2, right, is just going to give me a 2 by 2 matrix of 1s. So I'm going to get 1, 1, 1, 1. And then my D matrix is, as said above, 4, negative 1. That's not a 4. 3, negative 2. And so this is going to combine to be a 2 row by 1 column matrix. So stored in R is going to be our number of rows, which is 2, and then stored in C is going to be our number of columns, which is 4. So R equals 2, C equals 4. All right, moving on to number 2. We're going to have Mn is equal to find where our B matrix is equal to the mean of our C matrix. So if we real quick look at our C matrix, right, we have 1 by 2 to 6, so we're going to get 1, 3, 5, and the average of those 3 elements is just going to be 3. So basically, we are just trying to find the location of wherever B is equal to our mean, which is 3. So if we look at B, B is 1, 4, 3, 2, negative 3, negative 2. And so as we can see right here, there's a 3 right there. And this is in row 1, column 3. So M is going to store our row, and then N is going to store our column. So we get M is equal to 1, N is equal to 3. So now for number 3, we have X is equal to the max of 3 times 1's of 2, 1, concatenated with our D matrix again. So max is going to operate by column. So basically what we're going to get as a result of this, so we're going to get, so 1's 2, 1 is going to give us just a 2 by 1 vector of 3's, because we're multiplying the 1's by 3. And then we're just going to have our D matrix, which is going to be 4, 3, negative 1, negative 2. And then we're going to go ahead and calculate the max for each one of these columns, right? Which will just be 3, 4, and negative 1. So our X is going to equal 3, 4, negative 1. All right, moving on to number 4. We're going to get M is equal to the sum of A. So remember, sum will not give you the total sum. If it's applied to a matrix, it will just give you the sum of each column. So our A is equal to 2, 3, 1, 5, negative 2, 2. And so if we sum up each one of these columns, we're going to get 7, 1, 3. So then that's going to be stored in our M. All right, moving on to number 5. If Q is equal to our A matrix concatenated with our C matrix, and then attached to that we're going to get a 2 by 2 of zeros, and then attached to that we're going to get our B matrix. So if you notice already, this right here, A, is a 2 by 3, and our C, if we look above, is a 1 by 3. So already these two cannot be concatenated together, and we're going to result in an error right off the bat. So error, we don't have to go any further because we already know that it's going to error. All right, number 6. So we're going to have n is equal to the minimum of the maximum of our D matrix. So our D matrix, as we mentioned before, is 4, 3, -1, -2. And the max is going to give us the max of each column. So we're going to get 4 and -1. So our max of D is just going to look like 4, -1. And then we want to take the minimum of this maximum, right? So we're going to just take the minimum value in D, which is just going to be -1. So we're going to say that our n is equal to -1.